All right, so the purpose of this video is to introduce you to or to talk you through the notes that I put on Google Classroom. So this is angle relationships with the transversal. You'll notice that all the main vocabulary words are on this left-hand side with their definitions in the middle column and the actual angles that they refer to. So one of the things I wanted to let you know is I tried to color code it as best as I could. These are the notes from last year. So I tried to correlate it with color. One of the things that I'm missing here, just looking at it in retrospect, is this idea that these angle relationships, what they mean is that it creates congruent or equivalent angle measures. So let's start here with parallel lines. The green lines, M and K, are parallel. That means they don't intersect because they're always equidistant. This purplish color, burgundy color, that goes through it is called a transversal, line L. Line L is a transversal. It's a straight line that intersects a set of parallel lines. This guy is the reason all these other vocabulary words exist, because something special happens here. So the first word is called corresponding angles. So corresponding angles are congruent. Congruent means they have the same measure. So if I were to draw this circle around this, these intersecting lines, just these two, and cut it out and set it on top of this intersection, the ones that sit right on top of each other, those are corresponding angles. So angle A and E, they're corresponding. B and F, D and H, C and G. And the reason why they're corresponding is because they're angles that are in the same position relative to the transversal and parallel. So A is above the parallel to the left of the transversal. The only one in this angle relationship that's above the parallel and to the left of the transversal is E. So they're in the same position. If you were to cut it out and put it on top of each other, that's what that means, corresponding angles. Alternate interior angles. Alternate means opposite, so opposite of the transversal. We have the right side, the left side. And then exterior means outside of the parallel lines. Shh, Kinsley. So I have A, B, G, and H. Those are the only angles outside. So alternate exterior have the same measure, are congruent, and the matches are A and H. Kinsley, no. Baby girl, I'm recording right now. Sorry, guys. Then we have B and G, and that's it. So that's what we have here. Okay. Alternate interior angles are opposite the transversal inside the parallel lines. Well, the only four angles that are inside are C, D, E, and F. So now we have to match up the ones that are opposite. So C and F are called alternate interior. They're opposite the transversal, but inside the parallel lines. They are congruent. They have the same measure. E and D, opposite sides of the transversal, inside the parallel. Next, we have vertical angles. We should all remember vertical angles, right? They're across from each other. I had you guys hold up your V's and do vertical angles are across from each other. Vertical angles have the same measure. Okay, so vertical is like A and D, right? They're across from each other. They have the same measure. B and C, F and G, E and H. Next, we have same side interior. Same side interior would be angles C and E, meaning they're on the same side of the transversal inside the parallel lines. So this unique relationship between C and E is that they sum to 180 degrees. So C and E, Kinsley, I will take a point away. Kinsley, I will take a point away. Turn it off or put your headphones on. Sorry. So C and E sum up to 180 degrees. They're not the same measure. Okay. And how do I know that? Because C and D are on a supplementary, they're on a straight line. So then D and E are alternate interior. So if I know what D is, I also know what E is. So if these two sum to 180, then these two have to also sum to 180. Okay, so this is page 1 of the notes. Page 2 is an example. It's just a pair of parallel lines with a transversal. 5, 4, Kinsley, 3. Thank you. So I just was showing you which ones are same side interior, which ones were alternate interior, which ones are alternate exterior, which ones are vertical, which ones are corresponding, and which ones are supplemental or supplementary. And then we went into, okay, well, hey, what if I told you that one angle is 110 degrees? You only need one angle measure to tell what all the other angle measures are. So if I know what this angle is, I also know 2, because 2 is 110 as well. I also know 5. Okay, so I know 2 because they're vertical angles. I know 5 because they're alternate interior. That means that 5 is also 110. And I know 6 because 6 is vertical to 5. I also know 6 because 6 is alternate exterior to the measure of 110. How I would find everything else is due to supplementary. So I know 1 has to be 110 subtract 180, or 180 subtract 110. So this would be 70 degrees. So if I know what 1 is, I also know what 3 is. I also know what 4 is. I also know what 7 is, because they're all the same measure. Okay? So basically you have just 2 angle measures, or 2 numbers, sorry, in every relationship. Okay? And then the last thing is, well, what do I do when there's like variables? So if this one is 6x and this one is 6x, right, how do I figure that out? Well, the first thing I did here was I took 6x plus 3x and I set it equal to 180, because they're same side interior. It means these two have to add up to 180. So I added them up and I got 9x equals 180, divide by 9, and x is equal to 20 degrees. Now I have to go back in and substitute, right? So 3 times 20 is 60 degrees, and 20 times 6 is 120 degrees. So now I know this little zigzag here is 120, and this, the opposite way, is 60. Okay? And the same thing with the last example. So hopefully this helps. I will post this, and hopefully that will get you through those 4 little mini lessons. Okay, if you wish to copy down the notes, they're already posted in Google Classroom. Okay, have a great night.